Okay, so I was trying to get fit, bought these Saucony running shoes, and felt like I was what they call speed. Went for my first jog, feeling awesome, then wham! A stupid bird decides my brand new white shoe is a perfect target. Seriously, mid-run, right on my brand new shoe. Talk about a buzzkill. Now, only getting rid of all the birds on this planet could satisfy my rage, or maybe even a delicious Hershey's chocolate bar would do. Cleaning the bird mess off my shoe made me wonder, how do they even make these things? And how do they make Hershey's taste so good that it values the same as all the birds on this planet? Well, get ready, because we're going on a factory tour to see how exactly Saucony running shoes and Hershey's chocolate are really made. No marketing stuff, just machines, materials, and maybe some cool robots. Ready to see how it works? Well, let's dive in. First up, Saucony shoes. Where does a shoe designed for fast running even begin? Well, it's not made out of thin air. It all starts with very smart designers using computers. These are the Saucony shoe designers, and they plan out every single part of the shoe. They use advanced computer programs to design each piece. They create detailed digital models showing exactly how the shoe will look in 3D. They think about more than just looks, they study how a foot moves when running, how it lands on the ground, and how to make the shoe comfortable for long hours. They even create prototype shoes using rapid prototyping machines to test their designs. They test these prototypes by running, bending, and stressing them to see if the real shoe will hold up. If the prototype passes all the tests, the design moves forward. Once the shoe design is finalized, it's time to get all the materials needed to make it. This is the material sourcing stage. Picture a huge storage area filled with fabrics, rubber, and foam. Yeah, a lot of that. Saucony gets these materials from suppliers around the world. They require specialized mesh fabrics that allow for foot ventilation, durable synthetic leathers that can withstand wear and tear, and resilient foams that provide cushioning and energy return. Before using any material in production, Saucony conducts rigorous testing. Fabrics are tested for tensile strength and abrasion resistance. Rubber compounds are tested for flexibility and durability under stress. Foams are tested for compression and rebound properties. Only materials meeting strict performance criteria are approved for shoe manufacturing. This ensures the final product meets Saucony's quality and performance standards. Ever wonder about the secret behind light running shoes? Well, it's about using really advanced, lightweight components you might not expect. With all the approved materials in hand, their next step is precise cutting of shoe components. This is where automated cutting technology comes into play. Computer-controlled laser cutting machines are used to accurately cut fabric pieces. Laser cutting offers exceptional precision and the ability to cut intricate shapes without fraying edges. For thicker materials or components requiring different cutting methods, automated die cutting machines are employed. These machines use sharp metals to stamp out shapes with consistent accuracy. Every piece must be cut with extreme precision. Even slight deviations can affect the shoe's fit, performance, and overall quality. Precise cutting is essential for consistent shoe production. What safeguards are in place to prevent errors in automated cutting? Is there like a system to catch mistakes before they impact the shoe production? Yeah, and it involves some very clever tech. After cutting, the individual components are ready for the stitching process to form the shoe's upper. This stage involves skilled operators and advanced industrial sewing machines. Specialized sewing machines designed for foot-wearing manufacturing are used to join the various upper components. These machines can handle different fabric thickness and stitch types, ensuring strong and durable seams. Highly trained sewing machine operators carefully assemble the uppers, following precise patterns and instructions. Different stitching techniques are used in different areas of the upper to enhance strength and flexibility where needed. Reinforcement stitching is applied at stress points to prevent wear and tear during running. Accurate and robust stitching is vital for the upper's structural integrity and fit. Moving on to the sole unit, the focus shifts to molding the midsole and outsole components. This process relies on advanced molding techniques and specialized materials. Thermoplastic polyurethane or ethylene vinyl acetate foams are commonly used for midsoles due to their cushioning and energy return properties. These materials, in a molten state, are injected into precision molds under high pressure. The molds are designed to create the specific shape and features of the midsole, including contours for support and, of course, cushioning technologies. For outsoles, durable rubber compounds are used to provide traction and abrasion resistance. Similar injection molding techniques are employed to create outsoles with intricate tread patterns for optimal grip on various surfaces. Precise control of temperature and pressure during molding is critical to achieve the desired properties in the sole components. And with both the upper and sole components manufactured, the next critical step is bonding them together. This is the assembly phase where the shoe takes its final form. High-strength industrial adhesives, specifically formulated for footwear, are used to bond the upper and sole unit. These adhesives are applied to both the lasting margin of the upper and the bonding surface of the sole. Automated lasting machines are used to precisely position and press the upper onto the sole. Lasting machines stretch the upper around a shoe last, a foot-shaped mold to ensure proper shape and, fit during bonding. Consistent pressure and controlled adhesive application are essential for creating a durable and long-lasting bond between the upper and sole. But what exactly makes shoe adhesives so dang strong? Is it a special chemical formula, or is there a unique application process involved? Well, to tell you the truth, it's a combination of both with some really interesting science behind it. Following the bonding process, each shoe undergoes rigorous quality inspections as part of the finishing process. This stage is crucial for ensuring every shoe meets Saucony's high standards before leaving the factory. Trained quality control inspectors visually examine each shoe for any defects. They check for issues like, loose threads, adhesive residue, uneven stitching, or misaligned components. In addition to visual checks, shoes undergo functional tests. These tests may include flex testing to assess sole bond strength and durability, and fit checks using foot models to verify size accuracy and fit consistency. Shoes that fail inspection are either reworked to correct the defects or rejected if they cannot be brought up to standard. This stringent quality control process guarantees that only shoes meeting strict criteria are packed and shipped. Finally, shoes that pass quality control are prepared for packaging and distribution. This is the last step before they reach retailers and eventually consumers. Pairs of shoes are carefully matched and placed into individual shoe boxes. Protective paper or inserts are often used to maintain the shoe's shape and prevent damage during shipping. The shoe boxes themselves are designed to be sturdy and provide protection during transit. Boxes are then labeled with production information, including size, style, and SKU. Packed shoe boxes are then collated and loaded onto pallets for efficient shipping and distribution to warehouses and retail outlets worldwide. Careful packaging ensures the shoes arrive in perfect condition, ready for sale. So that's the detailed journey of Saucony running shoe production, from digital design to laser cutting, precision stitching, advanced molding, robust bonding, and stringent quality checks. It's a complex process to create performance footwear. All this effort results in comfortable, high-performance shoes ready for runners. Now let's switch gears and indulge in something sweet. Hershey's chocolate. No more shoe components, just creamy, rich, and satisfying chocolate. Have you ever wondered how those iconic Hershey's bars are made, ready to satisfy chocolate cravings? Prepare for a mouth-watering journey into the heart of chocolate production, filled with giant mixing tanks, flowing chocolate, and a whole lot of cocoa goodness. The Hershey's chocolate story begins with the sourcing of raw materials, starting with cocoa beans. Cocoa beans are the foundation of all chocolate, and Hershey sources them from various cocoa growing regions around the world. Upon arrival at the Hershey factory, cocoa beans undergo rigorous cleaning and sorting to remove any impurities. The clean beans are then roasted to develop their characteristic chocolate flavor and aroma. Roasting is a critical step, and precise control of temperature and time is essential to achieve the desired flavor profile. Following roasting, the beans are cracked and winnowed to separate the cocoa nibs from the outer shells. Cocoa nibs are the core of the cocoa bean and the key ingredient for chocolate production. Hershey's careful sourcing and processing of cocoa beans are the first steps in creating their signature chocolate. With processed cocoa nibs ready, the next stage is grinding them to create chocolate liquor. Cocoa nibs are then fed into large industrial grinders. These grinders use friction and pressure to break down the nibs into a smooth liquid state. The grinding process generates heat, which melts the cocoa butter present in the nibs, resulting in a flowing liquid called chocolate liquor. Despite the name, chocolate liquor contains no alcohol. I know, boo, right? It's pure unsweetened chocolate in liquid form. Chocolate liquor is the base for all chocolate products and contains both cocoa solids and cocoa butter. The fineness of the grind and the quality of the chocolate liquor directly impact the smoothness and texture of the final chocolate product. To create milk chocolate, like the classic Hershey's bar, chocolate liquor is combined with other key ingredients. This blending process is carefully controlled to ensure the correct proportions and flavor profile. Sugar is added for sweetness, and milk, in the form of milk solids or condensed milk, is incorporated to create the creamy texture and flavor characteristic of milk chocolate. Cocoa butter, an additional fat derived from cocoa beans, may be added to enhance smoothness and melting properties. Lecithin, an emulsifier, is often added to improve the mixing of ingredients and create a homogeneous chocolate mass. These ingredients are mixed in large blending tanks, ensuring thorough incorporation and consistent quality throughout the batch. The blended chocolate mixture then undergoes a crucial refining process to achieve the desired smooth texture. The chocolate mixture is passed through a series of heavy rollers in machines called refiners. These rollers grind down any remaining solid particles, such as sugar and cocoa solids, to microscopic size. Refining reduces the particle size to a level imperceptible on the tongue, resulting in a silky smooth mouthfeel. The refining process can take several hours and is essential for achieving the characteristic smoothness of high-quality chocolate. Proper refining is a key factor in differentiating premium chocolates from coarser varieties. So what's the secret to Hershey's unique creamy texture? Is it all in the ingredients, or, is there a special step in the process that makes it melt so smoothly? It involves a fascinating process called conching. Following refining, the chocolate undergoes conching, a critical step for flavor development and texture refinement. Conching machines are large tanks equipped with agitators that stir and knead the chocolate for extended periods. During conching, the chocolate is subjected to intense mixing, aeration, and temperature control. This process helps to remove unwanted volatile acids, further smooth the texture, and develop the complex flavors of the chocolate. Conching can last from several hours to days, depending on the desired chocolate profile and quality. The duration and intensity of conching significantly impacts the final flavor and mouthfeel of the chocolate. It's a defining step in creating high-quality chocolate. After conching, the finished chocolate is ready for molding into its final shapes, like the iconic Hershey's bar. Liquid chocolate is pumped into precise molds, typically made of metal or plastic. These molds are designed with the specific shape and markings of the desired chocolate product, such as the segmented rectangles of a Hershey's bar. Filled molds are then conveyed through cooling tunnels. These tunnels use controlled cold air to rapidly cool the chocolate and solidify it into the shape of the mold. Cooling is carefully controlled to ensure proper crystallization of the cocoa butter, which affects the chocolate's snap, shine, and texture. Once cooled and solidified, the chocolate bars are ready for demolding. Demolding is the process of removing the solid chocolate bars from their molds. Automated demolding equipment is used to efficiently and gently extract the chocolate bars. Molds are inverted or vibrated, and the solidified chocolate bars release and drop onto conveyor belts. The empty molds are then returned for refilling, creating a continuous production cycle. Demolded chocolate bars proceed to the wrapping and packaging stages. Efficient demolding is crucial for maintaining high production rates and minimizing damage to the delicate chocolate bars. Here's a surprising fact about Hershey's bar production. The iconic foil and paper wrapper is designed not just for looks, but for very specific functional reasons. The inner foil layer provides a barrier against moisture and air, protecting the chocolate's freshness and flavor. The outer paper layer provides structural support to the wrapper and serves as a surface for branding and product information. Hershey conducts rigorous testing on wrapper materials to ensure they maintain chocolate quality under various storage conditions and are easy for consumers to open. The wrapper is an integral part of the Hershey's chocolate experience. Finally, the demolded chocolate bars are conveyed to wrapping and packaging machines. High-speed wrapping machines automatically apply the inner foil and outer paper wrappers to each chocolate bar. The wrappers are precisely folded and sealed to ensure a tight and protective enclosure. Wrapped chocolate bars are then collated and loaded into cartons or boxes for bulk packaging. These cartons are labeled with product information and batch codes for traceability. Packaged cartons of Hershey's bars are then ready for distribution to warehouses and retail locations worldwide. Efficient and protective packaging ensures the chocolate reaches consumers in perfect condition, ready to be enjoyed. That's the inside scoop on how Hershey's chocolate bars are made. From cocoa bean sourcing to grinding, mixing, refining, conching, molding, and packaging, it's a detailed process to create everyone's favorite chocolate treat. All this careful work results in a smooth, creamy, and delicious Hershey's bar that we all know and love. You know what would be sweeter than a Hershey's bar and more comfortable than Saucony shoes? You hitting that subscribe button and giving us a big thumbs up. Seriously, it really helps our channel. We're kind of new here, so let us know in the comments. Are you craving chocolate now, or maybe ready for a run in some new shoes? Tell us what you think, and if you're hungry for more factory tours, check out our other videos. They're pretty cool. We've got lots more behind the scenes action waiting for you. Thanks for watching.